Okay, so we're going to do number 2 and 3 together here because they're similar. So in number 2, we have a pipe that's closed on one end. If we have a pipe that's closed on one end, we have to form a node on this side and an antinode on that side. We don't need anything in between them, which means the fundamental is going to be 1/4 of a wavelength. So 1/4 of a wavelength is going to fit inside this tube. And so if I know how long that tube is, it says it's 62.3 centimeters long, I have to change that to meters, so it's going to be 0.623 meters. So I just moved it 2 places because centimeters is a shift of 2 decimals there. So we want to know what's the fundamental frequency. Well, here I'm going to solve for the wavelength. So to get the wavelength all by itself, again, that's the fundamental. To get the wavelength all by itself, I'm going to have to multiply both sides by 4. That'll cancel it out on here and just give me wavelength by itself. So if I have 0.623 times 4, that gives me 2.492. Is my wavelength. Now if I'm looking for frequency, again, V equals F lambda. So if I'm looking for the frequency, I'm going to bring the lambda down here. So the V, of course, is always going to be 343 meters per second, and then the lambda we just figured out was 2.492. That gives me 138. Now, for part B, it said what is the first overtone's frequency going to be. So here we said that the fundamental was 1/4 of a wavelength, which means the first overtone is always going to be half a wavelength bigger. So half a wavelength bigger than 1/4 is going to be 3/4 of a wavelength. So 3/4 of a wavelength is still going to fit in that same tube. So it's going to be the same thing here, but now I'm going to have to multiply by 4 divided by 3, which means basically the only difference is in practical results. By the time we get down to the bottom, it's going to be 3 times bigger because we have this 3 built into here that we didn't have before. We had a 1 before. So basically all I have to do is take the answer there and multiply by 3. So if I take the 128 times 3, I get 415. So this is my A answer, this is the B answer. Now we're going to continue to use that same V equals F lambda formula for number 3. In number 3, we say waves have a frequency of 2 hertz, and the wave has a wavelength of 0.95 meters, and we want to know in A what is the speed. So of course my formula is V equals F lambda, so all I have to do is take those 2 numbers and multiply. Gives me 1.9 meters per second. So that was part A. Now for part B, it says as the frequency increases to 6, now all of a sudden F goes to 6 hertz. What's the new wavelength? Well, the frequency again I control, but the speed is controlled by the medium. So if I'm in the same medium, then the speed's not going to change. So I know my speed stays the 1.9 meters per second. So this time I'm looking for wavelength. So again, if I start with V equals F lambda, but this time I'm looking for lambda, the F needs to come over there. So I'm going to have the 1.9 divided by the 6. And that should give me my 8.06. And that's all there is for this.